All right, hello everyone. Welcome to our virtual planetarium show here at the Michigan Science Center. It is so great to see everybody today. Now, how we do our virtual planetarium shows here at the Michigan Science Center is we actually use YouTube as our chat feature. So if you have any questions during the program, feel free to put those in the chat of our YouTube program. Or I'll also ask you some questions and feel free to answer them in the chat. Before we get started, my name is Paulette Epstein. I am the staff astronomer here at the Michigan Science Center. So now that I've introduced myself, go ahead and introduce yourselves in the chat so I know who I'm talking about or talking to. So we're going to go ahead and get started with our program today. And like I said, we're going to be doing a virtual planetarium show. So we're going to go ahead and switch on over to our virtual planetarium. And we're going to take a look at the sky right now. All right, so here is our sky right now. If you were to go outside and face the direction north, this is what you would see. Now, I've set our sky to out in the country. I'm actually here in Midtown Detroit at the Michigan Science Center, and I actually live downtown Detroit. So my sky definitely won't look like this. But if you're far enough away from city lights, the sky is going to look a little bit like what I'm going to show you in just a moment. So this is what our daytime sky looks like right now. Now, looking up in our daytime sky, we might notice a couple of things, especially when we're looking over here in the southern sky. We're really close to sunset right now, so the sun is making its way below the horizon. But we are able to see the moon in the daytime sky. The moon is not always a nighttime sky object. Sometimes it can be seen in the day. And if we take a look at our moon and we zoom on in, we're going to see that our moon is something right now that we call a waxing gibbous. Waxing because it's on its way to being full, and gibbous is this shape that we call it right here. I think it's really fun to say waxing gibbous. So our friends at home, go ahead and say waxing gibbous. And remember, that's the phase of the moon that we're in right now, on its way to being full, and it's larger than half the moon. So that's what we call a gibbous. Now, it's a little hard to see it up in the daytime sky when we zoom on in because we still have a lot of light from the sun. Now, the atmosphere is actually what's lighting up. If we were to get rid of the atmosphere altogether, we would be able to see the nighttime sky all the time, even when the sun is up in the sky. But because we have an atmosphere, the light from the sun bounces off the particles in our atmosphere to create that blue sky that we normally see. So we're going to move forward in time. We're going to stop moving first, and then we'll move forward in time so that we can see our nighttime sky tonight. Now, this is a software called Stellarium. That's what I'm using right here. And Stellarium is a really interesting software that you can actually download at home. It's free software that you can take a look at the nighttime sky or what it should look like at home. So we're going to move forward in time just a little bit longer till about 10 o'clock. 10 o'clock is a great time of night to go stargazing for anyone, for any time of the year. Even in the middle of summer, it's still mostly dark by 10 o'clock. In the winter, it's definitely dark by 10 o'clock, and you might be able to do your stargazing just a little bit earlier. So when we're looking at our sky, we're able to see right now 3 really bright objects. We're able to see the planet Jupiter, the planet Saturn, and the moon. And if we look way over in this part of our sky, over in the eastern sky, we're able to see Mars. So we're able to see planets up in the nighttime sky just like we see the stars. And those planets are actually really, really bright. And we'll talk a little bit more about the planets in just a little bit. But first, I want to introduce you to some of our constellation friends up in the nighttime sky. And we're going to start over here in the northern sky. So in our northern sky right now, we are able to see 7 fairly bright stars. We count them 1, 2, 3, 4, 5, 6, 7. And when we draw lines between those stars, we can see something in the sky that kind of looks like a dipper. When we draw the lines between those stars, it sort of looks like a dipper. We call it the Big Dipper. Now, a lot of people look up in the sky, they see a dipper and they think it's the Little Dipper. But most of the time, if you can see a dipper, it's probably the Big Dipper. The Little Dipper is a little bit harder to find, and we'll go ahead and find that in just a moment. So our Big Dipper is right over here, and I can actually show you what it would look like when we're just bringing up the lines. Now, sometimes it can be really hard to go outside and see some of these constellations or star pictures when you look up and just use your imagination. I know my imagination sometimes isn't what it used to be. So what I like to do instead is I like to play a game of connect the dots, draw lines between the stars to make the picture. So here I have a constellation called Ursa Major, or the Big Bear. Now, you might look at this and think that looks nothing like a bear. And you know what? I don't really think so either. But we're going to have to use our imaginations in our virtual planetarium. So go ahead and use your imagination, and you might be able to see our Big Bear. But you might look at this bear and think, wait a minute, that bear looks ridiculous. That bear has a long tail, and bears have short little stubby bear tails. Why does that bear have a long tail? Well, you know, the Big Bear is also joined up in the sky with the Little Bear, which we have right up over here. The Big Bear has the Little Bear has the Little Dipper inside of it. You can use the two, we call them pointer stars, the ones in the front of the bowl of the dipper, and you can draw a line through those stars up to Polaris, our North Star, and then you'll be able to find our Little Dipper and our Little Bear up in that part of the sky. Now, these bears really do look ridiculous. They have long tails and they just look weird. But the story goes, a long time ago, the Greek god Zeus picked these bears up by their short little stubby bear tails, and he swung them around his head and threw them up into the nighttime sky. As he was swinging them around his head, their tails stretched out. So that's one of the many stories about these bears, why they're up in the nighttime sky and why they have these unusually long tails. Now, the really neat thing about these bears is the fact that they're up all year long. It doesn't matter if you go outside during the winter, the summer, the fall, or the spring, you should be able to find them. They're also something that we call circumpolar. And I'll show you what I mean by circumpolar. So we're going to turn off our atmosphere for just a moment. And we're going to move forward in time. As we move forward in time, I want you to do me a favor. I want you to pay attention to this star right here and tell me what happens. So we'll move forward in time, and we'll move a little faster forward in time. Looking up at the sky, what's happening to Polaris, or our North Star? Polaris, or our North Star, stays in the same spot. It doesn't move. And that's because it's almost directly above our North Pole, our North axis of rotation. We spin around on our axis like this, like a ballerina spinning around. And when we do that, the Earth does that, our North Pole, or the top of our head, is always pointed at this star right here, or at least pretty close to that star. Now we're going to go ahead and stop the sky from moving, and I'll reset to today's date, 26, at 10 o'clock. Now you might go, wait a minute, that doesn't look like 10 o'clock. It looks like 2200. Well, 2200 is what we call 10 o'clock when we're talking about military time. There we go. And we're going to stop the sky completely. So here we have our nighttime sky if we went outside at around 10 o'clock. Our Big Bear and Little Bear are back in their original positions. Excellent. There we go. All right. So if we look up in our sky and we take, let's see, let's go ahead and turn the atmosphere back on so it's a little easier to find some of our constellations. We're going to take these two stars right here in the bowl of the Dipper, and we're going to draw a line through them past Polaris, or our North Star, to these 5 bright stars right up over here. And when we draw lines between these stars, we might see something that sort of looks like an M or a W or an E or a 3, depending on how you're looking at it. But this is supposed to be Queen Cassiopeia. She was a queen in what we now call Ethiopia a long time ago. And she thought that she was the most beautiful person ever. She thought that she was more beautiful than the gods and goddesses. Well, you know what? That kind of made them angry. So Poseidon, the king of the sea, decided to send a sea monster to attack and destroy the kingdom. Another constellation up in our sky right over here, King Cephas, well, he didn't want his kingdom destroyed. So he went to the oracle, and the oracle is the person that knows everything in the universe. And he asked the oracle, how do I stop Cetus the sea monster? And the oracle told him, well, you can go ahead and sacrifice your daughter Andromeda. And we have Andromeda up in the sky right up over here. Now, being very good kings and queens and not so great parents, they're like, okay. So they tied her out to the rocks. Just as Cetus the sea monster was coming in to attack and eat Andromeda, Perseus, who just happened to be flying through with the shoes of Mercury and the head of Medusa, turned the sea monster into stone. Now, Perseus and Andromeda, they lived happily ever after, and Cetus the sea monster became a very nice statue in the middle of the kingdom. So, the constellations that we see up in the nighttime sky are not just random dots. I mean, they are. They're stars. But human beings have put them together into different pictures. And we've told stories about these constellations for as long as men have been around. So, for example, this is a story from Greek and Roman mythology. If we look at our Big Bear and our Little Bear, we can actually tell stories from Native American mythology. So, for example, the Native Americans, or some of the tribes in the United States, did not see super long tails on these bears. They actually saw that these bears were up in the nighttime sky, and these 3 stars following them were hunters following them across the sky. So when we take a look at these constellations, we're telling different stories from different points of history. Now, you might think, well, you know, Greek and Roman mythology, that's not from the dawn of time. But there's also stories from ancient China. There's also stories from ancient Babylonia. And most of the stars that we see up in the nighttime sky are actually named with the Arabic language. So there's all sorts of things up in the nighttime sky that lead us to history and really lead us to stories of our past and mythology. So these constellations are very neat up in the sky. You're able to see them in the northern sky, but it actually helps us find one of my favorite objects. So here we have Andromeda. And I actually like to draw Andromeda with another little thing right here, because then I have her head, I have her legs, I have her arms going across right here. And in Andromeda's armpit, you might be able to see an fuzzy blob of light. Now, you have to be pretty far away from city lights to see that fuzzy blob of light, but it's definitely there. That fuzzy blob of light can actually be seen with the unaided eye. Now, sometimes it can be hard to see really dim objects like that with the center of your eye. So what you do is use something called averted vision, which means you use the corner of your eye, and you look at some of the brighter stars like Merak right here, and use the corner of your eye to look that direction. And when we do that, we see my favorite nighttime sky object. This is not just a fuzzy blob of light. This is actually the Andromeda Galaxy. This is a group of over 1 trillion stars, 2.6 million light years away from us. This is a galaxy much like our own Milky Way galaxy. And the really cool thing is that they're on a collision course. In about 4 billion years or so, the Andromeda galaxy and the Milky Way galaxy are going to collide. Okay, they're not going to collide like that. What's probably going to happen is that most of the material will actually just go right through and won't even touch each other. But the gravitational fields might make them do a little bit of a dance. But don't worry, that's not going to happen for about 4 billion years or so. So still pretty cool. Now, the Andromeda Galaxy, like I said, is one of my favorite objects to take a look at. Now, if you have a pair of binoculars, which I always encourage people when they ask me what's the first telescope that they should ever get, I always recommend a good pair of binoculars, because I know it's not quite a telescope, but it helps you find some of these brighter objects to get your bearings, and then you're able to use a telescope a little bit better later on. So if you have a pair of binoculars, we can start to see some clusters of stars up in our sky. Now, if we look, let's see, we're not quite able to see it. But if we take away our atmosphere, you might be able to see it a little bit better. Right here, we're looking at the Milky Way, the galaxy that we live inside of. Since we live inside of the Milky Way galaxy, it's really hard for us to figure out what it looks like. So pretend that we live inside of a chocolate chip pancake. If you lived inside of a chocolate chip pancake, if you were one of the chocolate chips inside, you'd have a hard time figuring out what that chocolate chip pancake actually looks like too. You'd be able to see the edge of that chocolate chip pancake, like we can see the edge of the Milky Way right here. And you'd be able to see a few chocolate chips or stars on either side of you. But scientists have actually been able to measure the light coming from the Milky Way and of all of the stars up in the nighttime sky and the light from other galaxies like Andromeda. And they've estimated that we kind of look like a spiral galaxy. We look very, very similar to our friend Andromeda right here. We actually happen to have a bar in the center, at least we think. Because again, we can't travel outside of our galaxy and take a look. Now, I want to point out our planets one more time. Up in our nighttime sky, we have Mars, Saturn, and Jupiter. So these are really cool objects to take a look at with a pair of binoculars if you have a chance, because in a pair of binoculars, they look like different than stars. A star looks like a pinpoint of light, but planets sort of look like a floating sphere or floating ball out in space. And specifically, if you take a look at Saturn, it actually looks like a floating football because of the rings around it. Mars is actually really, really close to us right now. And so we're actually able to see Mars really bright up in our nighttime sky right now. Now, I mentioned Mars, Saturn, and Jupiter because I actually want to go to Mars, Saturn, and Jupiter. So let's go ahead and change our perspective just a little bit. And we are going to start out here on the Earth. So here we are orbiting around the Earth. Now this is a different software. This one is called OpenSpace. This is one that I like to use when I am trying to fly around the solar system. And so we're going to go ahead and start flying out. Now you might notice that we're actually flying pretty quickly. We're going to go all the way to the outer part, or we're all going to go all the way outside of our solar system here. And we're going to go ahead and take a look at what our solar system looks like. So just a little bit further, we of course have the inner planets. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So if we go ahead and head to the closest planet that we can see up in the nighttime sky, we are able to see right now Mars. So let's go to Mars. All right, so we're going to go ahead and zoom back in. We are heading straight on to Mars. There we are, coming up on our red planet. Red because it has iron oxide or rust in the soil. When we take a look at Mars, we can actually see some of the biggest features in the solar system. We're able to see a giant volcano on the surface. It doesn't work anymore, but a giant volcano on the surface called Olympus Mons. That's the largest volcano in the solar system. And then we also have Valles Marineris. Valles Marineris would stretch all the way from the east coast of the United States to the west coast, and it's over 4 miles deep at its deepest point. Now, Mars is an incredible planet, but I like some of the outer planets a lot better. So the inner planets are what we call terrestrial or rocky planets, and the outer planets are something that we call Jovian or Jupiter-like or gas giants. So let's head to our first gas giant in our solar system. Let's head to Jupiter. Now we're flying incredibly fast here in our virtual planetarium. And that's the good thing about computers. To actually get out to Jupiter, it would take us a while. because Jupiter is pretty far away from us. Now, Jupiter has something that we call differential rotation, which means that the top rotates at a different speed than the middle, which rotates at a different speed than the bottom. All of those different rotation speeds actually cause the planet and the gas in the atmosphere to twist. And that's why we get these beautiful clouds on the planet Jupiter. There's also a giant red spot on the surface. Can you guess what that giant red spot might be called? That giant red spot is called the Great Red Spot. And there it is. There's the Great Red Spot. Called the Great Red Spot because, well, scientists aren't super creative. We tend to name things what they look like. Now we're going to head to what's actually my favorite planet in the solar system. We are going to head to Saturn next. So let's go ahead and fly out to Saturn. Now, if we were on the fastest spacecraft ever, this would actually take us a couple of years. But luckily, again, here in our virtual planetarium, we are able to fly much, much faster. Now, Saturn, you might think of as the planet with the rings. Now, it's not the only planet with rings. Jupiter, Uranus, and Neptune all have rings as well, but Saturn's are the biggest and the brightest. So they're the ones that we think of when we think of rings. These rings are made up of chunks of ice and dust. Largest is about the size of a house. Smallest is about the size of a grain of sand. And even though the rings extend for hundreds of millions of miles from Saturn, you can see that they're razor thin. They're only about 30 feet thick. That's the height of a 3-story building. So Saturn is a pretty cool planet, especially when you want to take a look at it up in the nighttime sky. Like I said, because of these rings, it kind of looks like a floating football out in space. Now, we're going to go ahead and we are actually going to keep flying. So we've been able to take a look at some of the planets in our solar system and some of the things that we can see up in the nighttime sky. But we're going to keep flying out. We're going to turn around this way so we can see our solar system as we do. And remember that star-like thing that we were seeing? Yeah, that's the sun. Because from some of the outer planets in our solar system, the sun just looks like another star. As we continue flying out, we're going to start to see more and more things. We're going to start to notice that some things are moving. Okay, there goes the sun. Oh, we can start to see some of the stars moving as well. The further out we go, those constellations that we were able to see are nothing. We don't see them anymore. Soon, we'll actually be able to see our Milky Way galaxy. So we're going to zoom back in for just a moment there. There we go. Here is our Milky Way galaxy. Like I said, we look a lot like the Andromeda galaxy. But notice how our middle is elongated a little bit. We call that a bar. So this is what we think our Milky Way galaxy looks like. Now, we have traveled to where no spacecraft has ever gone before. Spacecraft haven't even made it outside of our solar system yet. And as we continue flying, our Milky Way galaxy is going to disappear. And we're going to start to see a lot of other things popping up. Now, these other things that we're seeing are not stars. These are galaxies, groups of millions, billions, or trillions of stars. We've estimated that there's about 600 billion galaxies out there. As we continue flying out, we're going to see what I like to call the cosmic butterfly. And really, this is just what the universe looks like from our perspective. It might not necessarily be spread out like this. And as we zoom all the way back, we get to the edge of our universe. We get to about 13.8 billion years ago, and we see our cosmic microwave background. So we're all the way out here at the edge of our universe. Now, once we get to the edge of our universe, I like to look back, and I like to remember that of all of these galaxies and all of these stars and our entire universe, 600 billion galaxies, millions, billions, or trillions of stars in each of them, planets around most of them, makes me wonder what else could be out there. Could there be life outside of our solar system? As we continue to fly in, we're going to start to see our Milky Way galaxy pop up again. And we'll get closer and closer to our home, to our planet. And even with all of those stars and all of those galaxies in our universe, there's probably life. But that life probably isn't like our home. People tell you that our Earth is the only one that we have, and it's true. Our pale blue dot is all we have, and we have to take care of our little planet, Earth. So we're heading on home to our planet Earth. And I hope that this helped you put things into perspective just a little bit and realize how small we actually are. But I also hope that looking at this, you know how small we are, but you know how amazing our planet Earth is, because we are just one planet around one star in one galaxy of an entire universe. And that's really what makes us special. All right, so we're back at the Earth, which brings us to the end of our virtual planetarium program. I want to thank everybody so much for joining us today. If you have questions, again, go ahead and put those on into the chat. If you don't have any questions, don't forget that I work here at the Michigan Science Center. We actually have live free programs on our Facebook page and our YouTube page. We have those live free programs every Wednesday at 2:30 for the fall. So check out those programs. Definitely visit the Michigan Science Center. We are open to the public with reduced capacity as well as increased cleaning. So definitely come check us out. We're still here, and it's going to be really exciting because October 9th, our theaters are opening back up. So I am so excited for that, and I can't wait to see everybody coming back to the Michigan Science Center. All right, not seeing any questions coming in. Thank you so much for joining me today. And I hope that you have a wonderful rest of the evening and enjoy the rest of the programming brought to you by GLAAC through the Astronomy at the Beach program. What they do is pretty awesome, and I love participating in GLAAC every single year. Hopefully next year we'll be able to do this in person. We miss you, and we'll see you next year.